Okay, I'm supposing you've seen this before, but I'm supposing also that you've never really seen the proof of this before. The quadratic formula. Suppose we have an equation. A times x squared plus b times x plus c equals 0. A, b, and c are real numbers. They're constant. They're not going to change. X is a variable. We want to know what value of x makes this whole thing true. Well, the first thing that we do is to simplify things. We move the c to the other side of the equation. Subtract c from the left, it goes away. Subtract c from the right, it becomes negative c. So we get x squared plus bx is negative c. Next, I want to have that x squared with nothing in front of it, so I divide both sides of the equation by a. So ax squared plus bx all divided by a equals negative c all divided by a. Now, when you have two things divided by a, we can divide each of them separately. Ax squared over a, the a canceled out. Bx over a is just b over ax. So we've got x squared plus b over ax equals negative c over a. A little bit of simplification. What do we do next? Here is where the last video comes in. You've seen this at the very end of the last video. X squared plus b over ax. This is the hardest part of the entire proof of the quadratic formula. You have to say, hey, to complete the square, take half of the b over a, that's b over 2a, square it, and add that to both sides of the equation. Where this comes from, it's because the Babylonians liked squares, and they could put that, this puts that last little bit in. Whatever b squared over 2a is, if b over 2a squared is, you add that to both sides, you will now get a perfect square. And the perfect square is going to be x plus this thing, x plus b over 2a. X plus b over 2a, the whole thing squared, is whatever this turns out to be. What do we do? Negative c over a left alone. B over 2a squared is b over 2a times b over 2a. We get b times b is b squared up top, and we have 2a times 2a down below, which is 4a squared. Next, we have two fractions on the right. We want a common denominator. What does this one have? Mark has an a, Amy has a 4 and 2 a's all multiplied together. Mark's jealous. He wants a 4 and an a, so we multiply by 4a over 4a, which is just 1. It's allowed to do that. That gives us a common denominator of 4a squared for both of these. We can combine these rather than say a negative 4ac on the left plus b squared. It's nicer to put the positive one first. So we've got the b squared minus 4ac, just putting this one first. All over a common denominator of 4a squared. The left is left alone. What do we do next? Next we can take the square root of both sides. This square will go away, and we'll get plus or minus the square root of the whole right-hand side. X plus b over 2a is plus or minus the square root of this whole thing, b squared minus 4ac over 4a squared. Now, when you take the square root of a fraction, you can take the square root of top and bottom separately. We can call this plus or minus square root of b squared minus 4ac over square root of 4a squared. The top, there's no simplifying that, but square root of 4 is 2, because 2 times 2 is 4, and square root of a squared is a, because a times a is a squared. So this whole denominator turns into just 2a. And then you can subtract b over 2a from both sides. It disappears over here. It becomes a negative b over 2a. We tend to put it in the front over here. X is negative b over 2a plus or minus this whole thing. We have two fractions. We already have a common denominator, so we can just combine these and get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is the general solution to any ax squared plus bx plus c equals 0. This thing is called the quadratic formula because this is called a general quadratic equation. Anything that has some number of constants, some number of x's, and some number of x squareds is called a quadratic equation. And, well, okay, if a is 0, then it's like we don't have any x squareds, then it's called a linear equation. If a is 0, we'd be dividing by 0 in this formula. That would be very bad. So when your a is not 0, this is what you've got. That's the quadratic formula. Ha! You've seen the proof of it now.